The Advanced Computing Center for the Arts and Design has been working in VR, developing a number of applications that expand and explore how virtual reality can be applied. In our work, we have discovered a fundamental disconnect between the viewer wearing the headset, exploring inside of the VR world, and the researcher who wants to observe and evaluate the immersed user's interaction in that environment. To create a more robust observation system for the virtual experience, ACAT has developed a mixed reality system and setup. By mixed reality, we mean a combination of live action mixed with virtual objects or scenes in a game world. In this case, we used an existing subway scene with a number of victims of a simulated terrorist attack. The immersed user is asked to perform first responder duties for each victim. While the user is virtually training with these procedures, an external observer wants to evaluate his or her performance and process. In order to be able to make this evaluation, the external observer needs to be able to see the immersed user's physical actions and the virtual world in which they are acting. Our typical virtual reality environment consists of the HTC Vive, handheld controllers, lighthouses, and the Unity game engine. This commercially available setup allows the user to interact with the real-time virtual environments. To integrate an external researcher, we have designed a system that uses live camera input of the immersed subject and composites the camera live action recording with the virtual environment, making it possible for an evaluator to observe all of the actions and views of the immersed user while they operate in the virtual world. This system begins by attaching a Vive controller to a live action camera. By doing this, a virtual camera that is created within Unity can be set to match the exact location and rotation of the physical camera at all times. Then, the virtual camera parameters, such as field of view, are tweaked to represent the live action camera, so the perspective from the camera in the real world and the virtual world are synchronized. The virtual camera gives us two important views based on the distance from the camera to the immersed user. First being the virtual background, which is everything behind the user, and second is the virtual foreground, or everything in front of the user. The immersed user in the Vive headset is then placed into a green screen environment. The live action camera captures the user against the green screen environment, which is then chroma keyed out, allowing the composition of the virtual foreground, live action camera, and the virtual background. The resulting feed is a video of the immersed user interacting with the virtual environment in real time, giving us mixed reality. In this way, while the immersed user is actively working in the virtual environment, the evaluator can see the live practitioner working within the virtual environment.